Hello, my name is Junhai Wang. I major in electrical and computer engineering.
Hi, my name is Zhihao Yu, also majoring in electrical and computer engineering. Our project is EDB-UNIQUE, which is edge detection-based unsupervised image quality estimation. Here introduce the working basis where we start our work from. With the high-speed network emerging and spreading these years, online applications have grown rapidly. At such age that almost everyone serves as the content creator and thus provides an enormous amount of media information, thus evaluating the quality of images in bulk is necessary and critical. Also, with the trend of cell phone manufacturers pushing bigger image sensors and higher-end camera modules to that digital device everyone always holds on hand or keep in pocket these days, together with the faster Wi-Fi and cellular network introduced recent years, the high-quality images are fast populating. Hence, there certainly appears the need of a better image quality estimation method that's capable of producing closer results to subjective human impressions.
UNIQUE introduced a new way to assess the quality of distortion image. UNIQUE uses an existing database to train a sparse representation model and represents image patch with another dimension vector, and evaluate the new image quality according to the new vector. From the right figure in this slide, we can see that the UNIQUE represents the original image with alert features and use the new image to judge the quality. However, we found that UNIQUE neglects many information in texture area. Since the edge features are insufficient to describe the texture, then we want UNIQUE to focus more on the edges in order to evaluate the distortion. The next part is the approach we used in this project.
As we were considering our approach, there are two parts that can be improved. For the pre-processing, there can be operations in frequency domain, and for the sparse representing, we can use optimized methods and new algorithm. Thus, we come up with two approaches, one of which is to apply the DCT filter to the pre-processing stage, and the other one is to apply the edge detection filter to the pre-processing stage and transform into 4-channel color space in the sparse representing stage. For the DCT approach, the ImageNet database images are transformed from RGB color space to YCBCR color space, and then apply the 8x8 block DCT transformation to the intensity, which is the Y channel, followed by the training procedures to obtain a sparse representation of the DCT images. Unfortunately, for the DCT approach, the results didn't turn out great, as the sparse representation shows too many highly uniform learned features, causing the results of image quality assessment not so convincing.
For the edge detection approach, as we can see in this slide, the left image is the original image. Then we apply YCBCR transformation to the original image and get the grayscale image. And then we apply the Laplacian filter to the intensity image. And then we will get the edge channel for the original image. Here is the pipeline for pre-processing. We will extract the green channel of original image and YCR channel of converted image, which is similar to UNIQUE. Besides, we additionally generate an edge channel. Therefore, there will be 4 channels overall. Then we randomly sample 100 8x8x4 patch in each image and reshape them into 256x1 vector. After mean subtraction and the ZCA, we will have the input for sparse representation training. Here we can see the result for sparse representation. The left figure shows the alert features for edge detection-based UNIQUE. We can see that there are more edge features than UNIQUE, which means the method will store more edge information than UNIQUE. This slide shows the performance of our new IQA method. The red marks the better performance in corresponding categories between edge detection-based unique and the original unique. The linearity shown by the Pearson correlation shows that edge detection-based unique works better in most cases, mainly because we use second power of correlation coefficient instead of tens. For accuracy assessment, a root mean square error shows edge detection-based unique performs better in both live or multi-live database. However, edge detection-based unique performs worse in those images with blur and noise distortion, mainly because noise distortion disables the edge detection filter.
As shown in the slide, similar behaviors can be observed in the scatter plots of EDB-UNIQUE for both live and multi-live databases. In the left-hand side scatter plot, the data points closer to 1, 0 are more uniformly distributed along the regression curve, while those on the other end are farther scattered from the curve. From the scatter plot on the right-hand side, all data points within both distortion categories are uniformly distributed along the regression line.
In this project, we changed the pre-processing method by applying the extended Laplacian filter to the intensity of the images and attaching the edge channel as the fourth channel of the customer-defined color space. With the changed image patch, we trained a new weight and bias for sparse representation. And then we validate the performance of edge detection-based unique works better than the unique in those images with blur and combination distortion.
According to the fact that the method is edge detection based, it will work best for more textured images. Also, with its good performance in compression and blurring categories, the method will work great for images shared online, as these images usually undergo compression before being uploaded. More than that, the method should as well work well for those pictures taken by unskilled people that includes blurring. However, considering its relatively worse performance for additive noise, pictures taken at night or in low light would be hard for EDB-UNIQUE to obtain a good result. Here are some thoughts after we finished this project. The scheduling was done great at the very beginning of the proposal stage. However, in reality, no matter it's our regular life events or pressure from other courses we took this semester, actual progress always falls behind the schedule. So what I'm thinking of right now is an adaptive schedule that evolves as our project proceeds, so that it can better meet the needs. Also, the papers these days are not only the paper itself anymore. Many papers are bundled with lots of code, or images, or data. As we already have indexing and searching systems for these publications, we might also need a new storage as well as detection or sharing system for any codes or files related to the papers, thus providing convenience and better referencing.
For me, since I am not specialized in image processing, my knowledge base is pretty limited in this area. And it is very difficult for me to have new ideas to improve a method that already published in a paper. Since the pressure from other courses, all I can do is to search way in the knowledge we have learned in the lecture. So I think if it is possible to make the project simpler in the future, such as achieve a small goal instead of making an improvement,